Let's now look at a useful property regarding line integrals and calculating the total work moving a particle along a path. Let's consider some force vector field that's contributing to the motion of a particle along some path C. Let's focus our attention on just a few of these vectors and the corresponding displacement vectors. When the angle in between these two vectors is in between 0 and 90 degrees, or essentially when the force vector and the displacement vector are headed in generally the same direction, the work done in this scenario is a positive quantity. But if we have a force vector field contributing to the motion along some path C, but the angle between these force vectors and their corresponding displacement vectors are greater than 90 degrees, this is a scenario where the work done by this force vector field is negative. Now, a property that we get when we're calculating the work by a force field moving an object along a path C is that if we're traversing this path in one direction and the vector field is generally moving in the same direction as the particle is moving, we end up with a positive work quantity. But if we were to change nothing but the orientation of that path where we are moving in this negative direction, let's now then call that negative C. We'll get the same numerical quantity for the work, but now it'll just be negative. So we can formalize this phenomenon by saying the work done moving an object along a path C will be the opposite of the work done moving that object along a path where we just reverse the orientation, which is basically what we have written down here. And there are problems where we can use this phenomenon to take shortcuts in our calculation.